So this video is about acceleration. The learning target for this lesson is the second half of this learning target, and it is I know how acceleration is measured and I can make calculations of acceleration. So this video is going to be focusing exclusively on how to make calculations of acceleration. So remember that acceleration is a change in speed or direction of an object. The speed can either go up or down, and going up would mean a positive acceleration, going down would be a negative acceleration, meaning that it's slowing down, or a change in direction because the velocity, remember, is made up of the speed and the direction. And so as we're calculating acceleration, the equation that we will use is this. Essentially it's change in velocity divided by time. Now, there's a couple different ways you can think about this. You can think of the change and you can actually just go through it in your head and say, okay, it changed 2 meters per second. Or you can say it changed -5 meters per second. Or you can break this down a little bit further. And so one way that we do this is VF, which means velocity final, and minus VI, which is velocity initial, divided by time. So the final velocity is whatever it ended up at after it changed. We have the initial velocity. You can think of this as like the starting velocity. And then obviously the T is the time in which the change occurred. So like for our when you have a dump truck, it hits the brakes and then all of a sudden it starts to slow down. That time that it is pushing on the brakes and slowing down is the entire time that the change happens until it comes to a stop, if it goes all the way to the stop. And so this is going to be the most useful equation that we will use through our calculations today, is velocity final minus velocity initial divided by the time that it took the change to happen. So let's look at this problem here. We have a bicyclist moving along a straight path at 2 meters per second. After 3 seconds, his speed is 8.0 meters per second. What was his acceleration during this time? So like any problem, we're always going to start off with what are we looking for? And in this problem, I am looking for what was his acceleration. And so that's what we're trying to find. And so we can start off with our equation of A equals, because we know we're looking for acceleration, VF minus V initial. Remember, my final velocity minus my initial velocity, and we're going to divide that by the time that it took this change to happen. And so now once we have our equation set up, we can just look at the different parts of this equation, V final, V initial, and T, and we can go find those in our problem, and we can decide, do we have these or do we have to do something else to find these? And luckily in this one we have them. And so my VF, my V final, is his speed after this change happened. And so we have after 3 seconds, his speed is 8.0 meters per second. So I know that my velocity final is 8.0 meters per second. I also know that my V initial is whatever velocity he started at. And so he is moving along a straight path at 2 meters per second before this change happened. And then after 3 seconds, his speed changed. But before anything changed, we know that his speed was 2 meters per second. And then we're looking for the time here, so we know that we have the time of 3.0 seconds. And so knowing your units is going to be really important here, so that if you know that meters per second is a velocity, that's going to help you out to pull this information off of the word problem here. Now we're going to be looking for his acceleration. And so now that we have everything that we need, we're going to start plugging things in. So I'm going to start with A equals, I'm going to use my velocity final, my 8.0 meters per second. I'm going to subtract from my 2 meters per second, and I'm going to divide by that 3.0 seconds to solve this. So if I want to simplify this, I would have 6 meters per second, which is the change that happened, and that's going to be divided by 3 seconds. And when I do all that math, I end up with 2 meters per second. And my units, notice here, my units is meters per second divided by seconds. And so there's a couple different ways that people will say this. They'll say 2 meters per second, because we're changing at a rate of 2 meters per second of our velocity every second. And so that's one way to say it. And another way that you're going to see it most commonly is you're going to see 2 meters per second squared. Because what's really happening here is if I take meters per second and I divide it by seconds, what I'm really doing is I'm multiplying it by the reciprocal 1 over whatever I'm dividing it by. And so then I end up with that meters per second squared. Remember, if we multiply fractions, we're really multiplying both of the bottom parts, the denominators, and then we're multiplying both of our numerators here. We end up with meters per second squared. And so this is what we end up with for our answer to this problem. So let's take a look at this problem. A car is traveling at 25 meters per second. When it has to stop to avoid a deer crossing the road, comes a stop in 2.5 seconds. And what is its acceleration during this time? So first thing we do in every problem is we look for what we're trying to find, and we are trying to find the acceleration during this time. So we're going to start off our problem writing out A equals VF minus VI divided by T. And we know that we're going to have to find VF, VI, and T. So let's go looking for that information now. Okay, so reading through the problem, it is traveling at 25 meters per second. So before anything happens, that's what it's traveling at. So that's going to be my V initial, 25 meters per second. When it has to stop to avoid a deer crossing the road, it comes to a stop in 2.5 seconds. So it comes to a stop. Well, what speed is it at if it is coming to a stop? It is at 0 meters per second. That's what it's ending up at. And we have our 2.5 seconds here. So we know that we have 2.5 seconds for our time. And so now, once we have all of these filled out, we have all the information we need, we can go and plug it in. So we have 0 meters per second for our velocity final minus 25 meters per second. And we divide by our time of 2.5 seconds. And then we can simplify this into negative 25 meters per second divided by 2.5 seconds, and that is going to give us an acceleration of minus 10 meters per second squared. And this makes sense because we know that it's slowing down, and so we end up with a negative acceleration. Last problem here for acceleration. I really encourage you to stop the video right now and try to do this one on your own before I go through the problem. So take a second, stop the video, try this one on your own. When you're ready to go, we're going to have, first thing that we do is what is its acceleration. I promise they won't all be written like this, but we know exactly what we're looking for. We're looking for acceleration, time right here. So we know that we're going to have to find velocity final, we're going to have to find our initial velocity, and we're going to also have to find the time in this problem. So the car speeds up from 0 meters per second, so it's starting there, 0 meters per second, to 21 meters per second. That's what it's ending up at, 21 meters per second. And it's doing that in 3 seconds. And so here's our problems that are our information that we need to have. And so once we have all of those information, we can go on and we can write 21 meters per second minus 0 meters per second. And we have 3 seconds. And we can tell that this is going to be a positive acceleration because we know that it's speeding up, and we know that speeding up is a positive acceleration. And so that's what this one ends up at. It is 7 meters per second, or meters per second squared. So by the end of this video, the goal was for you to be able to understand how acceleration is measured and to be able to calculate the acceleration of a moving object.